Okay, so we will jump into today's session, which is entitled Music Theory 101. Now, I know that we have plenty of people in the Zoom who will absolutely know absolutely everything that I'm going to try and cover this evening. That's okay. If you enjoy the refresher, that's brilliant. If you find it a little bit boring, or if there's no great value to it, I won't take any great offence if you decide to sign off. But if you'd like to stay with us for the duration, you remain very welcome. Um, the only other thing I think really to say is often when we talk about music, we are talking in metaphors or ways of explaining sound using words that don't necessarily relate to sound. So there are different ways of thinking about explaining and expressing the sort of things we're going to talk about tonight. But I will jump straight into it. So, really, the key question that we want to start with and try to get um, fully under our grasp by the end of tonight's session is this question of why do some notes sound good together? And how did we come up with the concept of organizing them into keys? And how can we make that work to provide us with a framework for writing songs? That's really what we're looking at in this session. The starting point really is to understand that the basic elements of music are not arbitrary. It's not just a bunch of things that one day somebody decided this is how music works. It really results from the nature of sound itself, it's actual physics. So you'll all be aware that vibrations in the air that we refer to as sound waves um, is how we and other animals actually perceive and interpret sound. Musical sounds or musical tones are those that have a kind of recognizable pitch that makes sense to us. What that actually means is the sound wave repeats a pattern rather than changing constantly. So, for example, if you were to get some kind of pictorial representation of a sound wave that's produced by just a noise, like the noise we make when we sneeze, you'll see a very irregular and unique jumble, and every sneeze is going to look different. However, if you do the same and look at a pictorial representation of a musical sound, you'll see the kind of shape that repeats over and over. It's kind of constant and uniform and organized. Um, and the faster that the repeating vibration happens, the higher in pitch we perceive that sound to be. So the faster the repeating vibration, the higher the sound we hear. And that's what we refer to as a frequency. How frequently it vibrates is a measure of how high or low we hear it. So a sound with a faster or higher frequency set of vibrations is something that we will hear as a higher tone. And if it vibrates more slowly, we hear it as a low tone. Now, in any single musical sounding tone, as opposed to a sneeze, you will actually find a number of different pitches or frequencies that are vibrating that we can discern as a musical tone within it. You might have heard these referred to as overtones or harmonics. There'll be a tone that corresponds to the main shape. There'll be a tone that is twice as fast as that. And we hear that as an octave higher. So a sound wave contains within it the basic sound, but also another vibration that's twice as fast as that basic fundamental sound, and we hear that as an octave. There will also be one that's 3 times as fast, which we hear as what we call a fifth above that. And we really have to get into scales before we understand what a fifth is. But this is really just to say that all of this stuff is actually in the sound wave itself. It is a kind of order that happens. Now, when you play together two different musical tones that have the right relationship to each other, some of these waves, these partials, the little elements that make it up, they'll match, they'll correspond. So to our ear, they will actually sound, they'll reinforce the sound of each other. It actually sounds like it's important that they go together. And if you play these two pitches together, they'll sound like two different notes, but as you hold them, as they continue to vibrate, they kind of merge into a single kind of sound, a kind of agreement. And this in physics is called the overlapping of partials. So all of this is to say that music, what we hear of music, actually occurs in nature. It's not something that human beings have entirely made up. But over time, different cultures found these to be natural stopping places in organizing sound into music. People could tell that pitches an octave apart sound like the same note, but higher or lower. And cultures all over the world reached that conclusion in their own musical systems. Musical scales were formed by finding notes between those two. So you've got your low note, you've got your high octave, and then different cultures have created scales by choosing notes that go between them. Just about every musical culture discovered the one that we call the fifth. They almost all discovered the one that's called the fourth, the major third, and then there's a whole load of other variations. But in Western music, we basically go through that kind of process and arrive at seven notes that we think sound like they all go together. We call it an octave because the eighth note is where the first one repeats. Um, about 1,000 years ago, somebody decided that we would give these notes the names of the Latin alphabet, A, B, C, D, E, F, G. I can't tell you why that happened, but that is just a convention that was agreed upon at some point. But we do know it's been in place, since a millennium ago. Now, if you take any two of these pitches from a single scale, so one note, let's say we're starting with the fundamental note, the root note of the scale, and you choose any other note to play with it, you will get some combinations that sound natural and sound pleasing or comforting, and we call that consonants. They sound nice together. Others are less comfortable or pleasing, and we call that dissonance. And when we hear dissonance, we often want it to stop by changing to consonants. We call that resolving, where it goes from a combination that's a little bit dissonant and it changes to consonants when you move it to one of the more comfortable notes. And that kind of tension is really key to how music works, moving from consonants to um, to that kind of dissonance and back again. And of course, if you use a note that doesn't belong in that scale, we often hear that as more dissonant, more jarring than the other notes. But I think, as we'll discuss in the next session with Nick, there's no dissonance that is so bad as to be wrong, as to be out of bounds. You can't use it. There is a thing called the devil's interval, but we won't get into that one. But in modern music, even the devil's interval is something that we can tolerate and think sounds okay. But what we're going to focus on today is the type of consonants and the type of dissonance that we feel most comfortable with, where we have these seven notes plus the octave that we think is okay. Oh, I can just see David's dropped out of the session, so I'll let him back in. Is everyone with me so far? If anyone has any questions, now would be a good time to maybe stick that in the chat. Otherwise, we'll move on a little bit. Okay, great. Everyone's happy with that? So the next question that we might want to look at is, what are chords? So chords are simply combinations of notes that we've decided to put together that create a harmony by having them played at the same time. Chords are constructed from any intervals in the scale, can be played on polyphonic instruments. That's an instrument that can make more than one note at a time. So obviously the guitar or the piano are two very good examples of that. Anytime you play two or more notes together, you're playing a chord. You will see YouTube videos on do chords really exist, and that's a whole nother existential rabbit hole you can jump down. But for now, we'll stick with the conventional thing that anytime two or more notes sound together, that is a chord. The most common, and you might say important type of chord, is called a triad. You might have heard of that. So a triad is made of up to three notes, and the fundamental ones are a root note, a third above the root, and a fifth above the root. So when we say a third or a fifth, we simply mean if we put those notes in order, those 7 notes in order, the first one is the root note, the second note is simply called the second, the third note is the third, the fourth note is the fourth, the fifth note is the fifth, sixth, seventh, and then the octave. So if we get that first note, then the third note, then the fifth note, that will give us a triad. And that's the most fundamental sort of building block chord we're moving forward with. The difference between major and minor chords comes down to a very simple one, and it is the third note in that scale. So a major chord that you will have played many times if you play guitar or piano contains the first, the third, and the fifth note of the major scale. A minor chord contains the first, the third, and the fifth note of the minor scale that is named for. The difference is the third will be one semitone lower for a minor chord than the one for the major chord. And that's the fundamental difference. We are also going to be looking at something called the diminished chord today. A diminished chord isn't as scary as it sounds. It's just a chord made up of the root note, the minor third, and what we do is we lower the fifth by a semitone the same way we lowered the third to get that minor. So we don't call that a minor fifth, however, it's just called a diminished fifth, which means that. So I'm just going to switch my camera now over to a little keyboard here that I have set up. Hopefully you can see that now. Right. And I don't know, can everyone see that big, or do I need to switch to speaker view and make that big? Is that big enough for everyone? It's okay? Great. So if we're talking about the scale of C major, it's all the white notes, C, D, E, F, G, A, B, and there's C again. So the C major chord would just be the C, then the third, and then the fifth. If we wanted to play a C minor chord, we just lower this by one note, one semitone, because that's the third. People can't hear that very well. I'll turn that up. So, is that coming through any louder? Oh, I can see why. My sound filter is turned off. That should be better. So, Is that loud enough for everyone now? Okay, there's our major chord. There's our minor chord, taking that third note down a semitone. And if we wanted to play a C diminished chord, all we would do is take that one down, and then this one here is also going to come down. There it is, the C diminished chord. And you should be able to hear that dissonance I was talking about. That sounds like you want it to stop and change to a different note. If we go from the C diminished to the C minor, that's moving from that dissonance to that assonance. Okay. So the next question that jumps from there is, how do we know which chords we should use for a certain scale? Now, I am going to, in a minute, bring up a little diagram that's going to help us with this. But essentially, this is what we call keys. That's what this is all about. There we go. Let me just close that. So the way keys work is, a musical key is the idea of the group of the notes that go together in a musical way and appear in either a major or minor scale together is a key. Working out which chords fit within that key is known as harmonizing the scale, or you can think of it as you take a scale and you use it to construct a key. So what I'm going to show you now is essentially the mechanism by which we can count out and basically work out, if we know what our scale is, therefore what are the chords that fit with that key. Now, one thing I need to make really clear is that what we're talking about here is a section of music theory called diatonic harmony. And that is basically where we're following the simple rules of sticking to the notes that belong by convention of what we think sounds good to a key. Sometimes when people come across this for the first time, they think these are the rules and all notes fit into this and all songs should follow it, which, as Nick is going to demonstrate next week, is not actually the case. But when you decide we are following these rules, you're just, I like to think of it as there's two universes of music. There's the diatonic universe, where the simple rules of physics apply, and the non-diatonic universe, where you're allowed to break those rules and bring in other things and, you know, weird elements that might operate in a different way. So we're going to stay focused on this diatonic universe for now. So first of all, let me switch over and show you my little diagram. Is that working for me? Hopefully you can see a diagram now. There we go. Let me just close that. So this is a diagram that I've taken from Your Guitar Academy. Those of you who were in the first Clash Mob, right, remember Dan, who made a fantastic video for us showing us how to play Should I Stay or Should I Go on the guitar. This is his nice little diagram for explaining harmonizing scales and constructing keys. So what we've got here is a really nice little diagram that sets out the notes C, D, E, F, G, A, B, C, the notes of the C major scale. And what you can see he's done here is he said, well, if we build a chord by putting the C, the E, and the G, that'll give us the first, the third, and the fifth. So I'll play that over here. C, E, and G. Perhaps I can switch to my other camera at the same time I'm doing this, or perhaps I can't. I'm not sure about that. See if I can. Maybe I can't do that. There we go. There. There's our C, there's our E, there's our G. So we're playing a C major chord. Applying the exact same theory, if you look back at the diagram, if we want to know what chord D is going to give us, all you do is exactly the same thing. You go D, you go up to the third and up to the fifth, just counting up in the scale in exactly the same way. So that's what he's doing in this diagram here, the second one, D, F and A. So on the keyboard, D, F and A, so that you can see these are the notes that all belong in this scale, and D is going to be a minor chord because in relation to D, that is a flat third. So you can hear that it's got that sad minor sound. Well, hopefully you can hear it. Now if I do exactly the same thing a third time and do E, G and B, that tells me the chord that I need for E is also a minor chord. So you can see every chord that we build is just using the white notes because that is our scale C, D, E, F, G, A, B, C. We can do it again for F, F, A and C. If we look at our diagram here again, F, A and C. There it is, F major. Then the next one we have G, we've got G, B, and we've run out of notes here, but of course it repeats. So we know we're back at D. So we've got G, B, and D this time. So that's going to be G major. Then for A, we're going to have A, C, and the next one is going to be E. So we've got a minor chord again, A minor. Then for B, here's the interesting one. We're going to have B, and the third is going to be D, and the fifth is going to be F. There's that diminished chord that I mentioned before, because the third is flat, and so is the fifth. You can hear it in relation to that C chord, which has lots of that consonance, those notes that sound like they go together, whereas there's a lot of dissonance in this B diminished chord. Now, what's interesting about this is we now have a formula. Instead of working that out every time, now you know how this works, you can actually just learn this pattern and this will work every single time. So for every major scale, if you write out the notes of that scale, you can use this formula, which is labeled the 7 chords of a key, and that will tell you exactly what each of those chords should be. So we've got the root note will always be major, the second will always be minor, the third will always be minor, the fourth will always be major, fifth will always be major, the sixth will always be minor, the seventh will always be that weird diminished one, and the eighth, which is the octave, will also be major again. Okay, so that is essentially a great shortcut way, once you know what key you're in, to know exactly which chords are going to harmonize and make sense in this key. The obvious question that's probably in a few people's minds right now is, what about a minor scale? So a minor scale works exactly the same way because every minor scale has the same notes in it as a major scale. There's a thing called a relative minor. So every major scale has a minor scale which has the same notes in it. And in the case of C major, our example at the top of the sheet here, the relative minor is A. And it is always, if you start at the octave and come down, it is the second note down. So it's always, or if you count from the bottom, the sixth. This note here is always the root note of a relative minor key, whatever scale you have. So in the case of C major, A minor will be your scale. And again, I'll demonstrate this when I go back to the keyboard. If I want to play an A minor scale, I start on A, and it's all the white notes again, but I started on the A instead of the C. So what that means is that our formula still works. It's just this is going to be our one. Instead of going major, minor, minor, major, major, minor, diminished, major, it's going to start here and it'll be minor, diminished, major, major, minor, minor, major, major. So in a minor key, the second is going to be diminished, whereas in the major key, it was the seventh that was diminished. So I'm hoping that that makes a bit of sense. And to answer Ellie's question, yes, this music theory sheet will be sent out to everyone. Probably won't have time tonight, but it will be sent tomorrow to everyone who registered for this group. And you'll be able to have this for future reference. What I recommend doing is taking another scale, maybe even doing this a few times, and writing it out and actually putting it into practice yourself. That will really sort of embed it and bring it home to you. Another really important thing, of course, is if you play guitar, you're probably wondering, how the hell do I play a diminished chord on the guitar? And here are two diagrams of two different ways to play them. Now, the diagram here is for the B diminished, which is the chord, obviously, that we have been using in this example. But the root note of this pattern on the bottom E string is a B. So you can move this up and down the neck to give you a first position. This is kind of based on a bar chord, but obviously you haven't got to bar your finger because it's not really necessarily going to help you. You could, but you don't want to play these top two strings. But these four strings in that pattern, whatever note this first finger is on, it will give you that diminished. So that's a B diminished. If you moved it down one fret, that will give you a B flat diminished. If you move it up one fret, that will give you a C diminished. Or you can play it further down towards the nut and ignore both E strings. Just play the four strings in the middle. This is a second position version of the diminished chord. You'll see it's almost the same shape. You have these three notes in a row, but this one is a fret higher, so you have to finger it differently. But that will give you a B diminished, and again, one fret lower will be B flat, one fret higher will be C. There's a C sharp. D diminished would be here. So again, when you get this sheet, you might like to experiment with that and see where that takes you. Okay, Tim, I'm going to shortly get to your question about sixths and minor sevenths and so on, but we will, actually, why not? I'll start that now. So We can actually arrive at some more complex chords if we want to. So basically, up till now, we've just talked about triads, and major and minor triads, and the diminished triads sort of look the same. So let me just switch back over to the keyboard camera. There we go. So you can play, and you may have come across a chord called a fourth before. Usually a suspended fourth is what we call it. All we're going to do is take this third note, so we'll stick with C. Here's C major. We're going to take this third note and we're going to take that up to the fourth. So instead of playing that, we're going to play the fourth. Now you can hear that that's very close to the fifth. So what you might like to do is, particularly pianists do this, is they might like to play the fifth way up here and do something like that. Or they might like to play that fifth and play the fourth all the way up there. So they might play that sound and spread the chords out, but you can actually play them very close together, and it actually provides a very rich kind of dissonance that wants to be resolved back to that third. There are so many songs that do suspended fourth to the major chord. In fact, I might just change my sound here. No, that one's not going to be much better, is it? Let me just go. A lot of songs that have that kind of sound to them. I might just go to a nice string sound. Okay, so that is going from the fourth. You can also create a second, which is, again, we're going to take this third and we're going to move it down, playing the second. Again, you might think that's too close to our root note, so you might like to play the root note up the octave. So we've got our second, our fifth, and the octave sound. All right. Well, let me see if I can get a sound that cuts through a bit more. Yeah, it's sounding a bit funny, isn't it? Oh, I know why. I've got this weird effect on. Just turn that off. You can probably hear that more clearly. Now, if I want to play my first and fifth here, which, by the way, you might often hear referred to as a power chord, which is just when you leave out the third altogether and you don't care whether it's major or minor, you just play the first and the fifth. Then we have our fourth, bring in our third to make it a major, and then our second. There are so many songs that use combinations and patterns of those. You will have heard many, many songs that do that kind of thing. So that is our fourth and our second. We can get some other more complex chords. So you may have heard of the dominant seven, often just called a seventh. That is an interesting one because we play, so if we're in C again, we play our major third, our fifth, and what we're going to do is add a minor seventh, which is flat. Now you'll see that doesn't belong to this diatonic universe, because instead of playing this note, we've added that one with my pinky. That little pinky note there is a flattened version of the seventh we'd expect to hear. So what we actually have with the dominant seventh is a major third and a minor seventh, which creates a lot of dissonance. And what you will often hear is blues songs that use the seventh, because it always makes you want to go somewhere else. I often liken it to the blues is about wanting to go home but not being comfortable when you get home, so you go off again, which is why the blues cycles around in that pattern so comfortably, because the dissonance never quite resolves thanks to the seventh. But just a little songwriting tip is, if you want to use the dominant seventh, it actually sounds good if you do it with the fifth, even though we're borrowing a note from outside the diatonic universe. So if we're in the key of C and we go to G, if we want to add a dominant seventh to the G, that's a flat 7. And what do you notice? It's a white key. So if we want to make the fifth chord a dominant seventh, we can still stay in the diatonic universe and get that sound. But a lot of the other chords will take us out of the diatonic universe, so they won't quite work. Now, if we go back to the C seventh, if I add that seventh that we expect to hear, the one that's in the white notes, so therefore in our key, that will be what we call a major seventh, a 4-note chord. We're playing C major, and we're adding the seventh, which is also major. So that's called a major seventh. If in the case of D, if I have a D minor, and I add the seventh above there, that is also going to be in key, but it's actually a minor seventh from the point of view of D. So we would call that 4-note chord D minor plus the seventh. That will be D minor seventh. So you can add these and still you're in the diatonic universe. You've got your major 7, your minor 7, and in the case of the 5th degree of the scale, you can have a dominant 7th. Really, the last thing that I wanted to cover is the idea of other notes that extend beyond the octave. So you may have heard of something called the 9th, the 11th, or the 13th. Has anyone heard of those? All we're really doing in music theory is keeping on counting. So when we get to 8, if we go up one more, we can call that the 9th, just to indicate that we mean this D here, not this D down here, that we call the 2nd. So if I wanted to play a C9, what I might do is play the 1st and the 5th, and then instead of this 3rd, I'll go and play all the way up there. Whoops, wrong note. That D. That would be a 9th. 1st, 5th, and 9. Now, if I want to, I can play this major 3rd and still play the 9th. I might want to use 2 hands. Or I can leave that one out. You might call that a major 9th if you want to be pedantic. You can also keep going with that. So you could add the 11. So if this is 9, 10, 11, what note is that? That's actually the 4th, an octave higher. So that will give us the 11. again, just play the root note, the 5th, and the 11th. You can hear how much dissonance is in that. It wants you to go to another note. There's our nice consonant major sound going from the 11th, 4th. We're really just playing a major scale, but the major chord, sorry, but the 3rd is all the way up here. We don't call that a 10th. It's only really these notes that are adding tension that we bother to name. People would actually refer to this chord, which is 1, 5, and if you like 10, as just a different inversion of the major chord, because we're playing the major chord, we're just playing the 3rd all the way up there. The other common one you might hear of is the 13. So if that's our, where are we? I've got lost now. If that's our 11, 12, there would be 13. And we might play the octave a bit closer and the 5th down below just to spread the chord out. Again, a lot of dissonance in that. It wants to resolve somewhere. And what you'll hear when you start experimenting with these, especially if you experiment with the diminished chord, is that that is a chord that really, really wants you to resolve it by taking it to one of the most comfortable or consonant sounding chords that are nearby. And I think that is about the end of my list of things I wanted to make sure I covered today. I think Nick has got something to add.
Yeah, Scott, could I just take you back to when you were talking about working off the C chord, sorry, the C scale to find the chords that fit that particular key.
Yeah.
I don't know if I missed it, but the scale doesn't have to start on a C, does it?
No, not at all.
So if you start on an E, for example, to get the same relationship of notes to create that scale, could you just take us through that? Because maybe we want to start with a different note.
Yeah, no, absolutely. So let me just switch back to the other camera. And do let me apologize that I am not really a pianist, and I haven't memorized all of the scale shapes the way that I should. But let's take the example that Nick said. So if our scale was E major, our second is going to be F sharp. Correct me if I get any of this wrong, Nick. So our third is going to be G sharp. Our fourth is going to be A. Our fifth is going to be B. Our sixth is going to be C sharp. Our seventh is going to be D sharp, or should we be saying E flat? I'm never sure how that's meant to work. And then we get to E. Whoops. No. There we go. So that's E major. So you can see we've got 4 black notes. So we're dealing with a whole different thing.
Yeah, absolutely. I just think it's quite interesting to see that the relationship between the tone and the tone, tone, semitone, tone, 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 semitone relationship starts wherever you want to on the keyboard or the guitar.
That's exactly right.
The pattern is the same. So when you're working out your chords, you can work it out from there.
Yes. So in this case, our E chord is going to be the first, our third, and our fifth. Our second chord is going to be F sharp. Whoops, you can't see that with my fat fingers there. There we go. So that is going to be an F sharp minor chord, which is is going to be full of black notes because we've just moved to a different part of the keyboard by moving at a different starting point. But exactly as Nick said, and I'll go back to my little diagram here, the same way that we have this pattern that always repeats for every key, the same way for scales, the same intervals will appear. So if you look over here at my keyboard again, what Nick was referring to is from C to D is a tone, because you can see we're skipping a note. We're skipping the C sharp. And the same to E. So it goes from the root note, a whole tone jump, then another whole tone jump. Then to the fourth is always a semitone jump. Then another whole tone to the fifth, another whole tone to the sixth, another whole tone to the seventh, and then the octave is just a semitone away. And that is going to happen every time. So if we were doing C sharp, move everything up by one note, then you're going to see the first note is going to be a tone. The next note is going to be a tone. The next note is only a semitone. So we know it's going to be that F sharp. Then we're back to a tone, another tone, another tone, and then the semitone. So with that formula, you can work out any note you want to start from. That will give you the major scale. And then if you go to the sixth note, that will give you the relative minor scale. Or if you want to think of that a different way, so it's just a different starting point of the pattern to work that out for a minor scale. So I said before that A minor was the relative minor of C. You can see from A minor we've got a tone, then a semitone, then a tone, then a tone, then a semitone, then a tone, and then a tone. Like this, it's the same pattern, but you're starting from a different point. What I might do before I send this sheet out is add that to the bottom of the sheet, that tone, tone, semitone pattern, so you can see and refer to that going forward as well. So, any questions? I hope, if there are, that I can answer them, or throw a Hail Mary pass to Nick, who might be able to. But yes, I will definitely add that to the bottom of the sheet. There's a question from Richard, which is about why have semitones rather than just more tones? It is actually just, it's going back to that physics again. When you actually observe the sound waves, it's just where the resonances are and where it makes sense that we have pulled out 12 notes. And the ones that work together in harmony follow that pattern that jumps. If you're in a different musical tradition, such as Indian music from India, as opposed to American Indian music, you'll find that there is generally a lot of similarity, but a few intervals they've chosen that are different. In American Indian music, they didn't like the sixth at all. They got rid of that. They didn't like the second at all. They never used it. What they used is pretty much what we would recognize as a pentatonic scale, because they tended not to use those two because they were too dissonant for them. They actually preferred the assonant, consonant sounds in their culture.
Okay, so it's cultural, yeah?
It is absolutely cultural, yes.
Cool. All right, thank you.
And so, yeah, we're sticking entirely to the Western music tradition in this session. Okay, so I hope that this has been a really helpful session, and that if some of this stuff was mysterious to you before, you've now been equipped with something that helps you to explore it and lock it together. And as I say, will add the scale pattern to the sheet and send that out to the email address you registered on the Eventbrite with, hopefully tomorrow morning. If there are any last questions, please fire away. Otherwise, we'll sign up. Oh, Nick's got something to add.
Sorry, Scott. Just to say, has the issue of logging in been resolved for next time?
Yeah, I think so. I think what we will do is I will double check with Elliot that we have got a single meeting and a single login, and we will make sure that everyone has the same one.
Would it also be possible to have access to the actual login number and code as well, those two numbers?
Yes.
That would be really useful. I should probably log in on two devices because one of mine tends to glitch every now and then, so I'll use one for audio and the other one for visual, something like that.
Okay, yeah, not a problem. We'll
Thanks.
include that. Ellie's got a question.
Hi, I'm just sort of wondering, because it might just be my dyslexia and ADHD. I struggle to sort of take in a lot of this information, and I know there's a sheet that you can send out, but some of the language, like the way the languages can be written, can be a bit confusing, and I wondered if there's any kind of theory explaining this in a way that's quite simplified, because sometimes the language gets a bit confusing. I don't know if you know any books or anything that can be helpful to memorize it better.
Yeah. The short answer to that is no. And in fact, what I was really hoping to achieve today was to explain what a lot of these shorthand words like diminished and major and minor actually mean and refer to. The problem that we really have is that when we're talking about sound, the English language doesn't really, and not just English, I think human language in general, doesn't really have a great way of describing things. We tend to use metaphors to try and describe how things work. I think what might be most helpful is if I can also share the link to the recording, and if there are bits you want to revisit and go back to, hopefully watching it a couple of times might help get you there.
That would be really helpful. Thank you.
Yeah, you'll be very welcome to do that. I'll do a little research as well and see if I can find something that perhaps is particularly written or pitched for a neurodiverse audience or something like that. But yeah, it is difficult because even stuff that's pitched at primary school students tends to just be, this is the language, this is what the thing is called, and is often about learning it by rote rather than understanding how it's made and what it means so you can do it for yourself, which is really what I was hoping to do in this session.
Thank you.
Absolutely take your feedback on board, and we'll see what we can do about that.
Thank you. Thanks very much.
An interesting thing is with keyboards and guitar. With a guitar, it's you see all the semitones just one after another, da 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 da. 1, 2, 3, 4, 5, 6, 7, 8 going up. With a keyboard, you've got the black and white notes, and obviously, when you learn a keyboard, you have to learn how each of those, starting on each note, how each of those, the major and the minor, go, and that's a massive processing thing, isn't it? It's easier on guitar in some ways, because you've got a major shape or a minor shape and just slide it up a semitone and da da da, whereas to do that the same thing on a piano is really something you have to learn.
Yeah, that's absolutely true, David. And in my experience, it tends to be precisely why pianists and keyboard players actually know the names of all the notes they're playing, and guitarists often don't, because we tend to play by shape. But in the end, they're both ways to arrive at the sound. And in some ways, it doesn't really matter what it's called. We're trying to arrive at a sound.
Yeah.
And it is interesting that particularly in places like Nashville, when people who play different instruments and come from different backgrounds come together to play, they often don't refer to the names of the notes at all. They just refer to what key they're in, and then everything is about the interval. So they might say this chord progression, they don't describe it as C, G, F. They would describe that as 1, 5, 4.
The numbers, yeah.
And they use Roman numerals to make it clear they're talking about the chords as opposed to the degrees of the scale. And that is something that is really a shorthand way to arrive at the relationships between different sounds rather than what name we happen to have given them. And when you think about how this sound works, it is about the relationships between different notes in their context, in the context of the key you've chosen, if you like, that actually is the most important thing, rather than what anything is called. Okay, any more questions?
Just another comment. I don't know if Ellie's still there. Are you still there, Ellie, or not?
Yeah, I'm still here.
Yeah. Oh, it's just saying, one of the things I found quite useful, although I haven't used it hugely. Oh, I'm muted.
No, you're not muted. We can hear you, David.
No, I got a set sign up saying I was. Photo has when she does one of her songwriting workshops, she has a couple of sheets, and it's like a tablature of every note, and then every key, and then going across, it's got 1, 3, 5, 1. All the different types of chords you can have within a key and their relationship in a block visual format, which takes it away from the keyboard, and you just see literally the notes, and then you can find them on the keyboard if you want to, or you can find them on your guitar if you want to. I found that useful at certain times, looking at that chart. I don't know if that makes sense.
Yeah, I think that does make sense. I think I'm visualizing it right now. I think it was more just trying to remember what is a diminished note and remembering the seventh, because I can hear the difference between major and minor quite well, but it's just memorizing. Like I've remembered really well, like the when it's saying about working out the chords, and you go from the first, third, and fifth note, but I forgot for the minor, like how if it's working it out the same way. I couldn't quite remember everything that was said. That's all. I think my memory's just being a bit rubbish. That's all.
That's all right, Ellie. I think when you've got the sheet and the link, and you can refer back to it as many times as you need to, hopefully that will get you there.
Yeah. Thank you.
All right. Well, thank you, everybody, for being part of today's workshop. I would suggest, if you do have the time, to revisit this and try applying it to a different key to C. Just pick any scale you like, write it out, and go through the process of harmonizing it. That will really bed down your understanding. And if you can do that before next Tuesday, when Nick will start taking you out of this diatonic universe and showing you some other interesting things you can do and some ways you can change or vary your note palette to arrive at some more what's the word I'm looking for? Adventurous sounds, shall we say? And that might be a great next step for you, or something that you can put in your back pocket to try a bit later on. Then we're going to have a week's break, and then there will be the session on lyrics, where we're actually going to start with the really important question of what makes a great song, and then we'll be exploring how much lyrics matter, how important lyrics might or might not be to arriving at a great song. So we shall see you soon. Thanks very much.
Thank you.
Bye.
Bye.
Thanks a lot, Scott.